Okay, so last week we talked about areas, right? We talk about areas of rectangles, triangles, parallelograms, and other figures. Now we're going to move on. We connect those shapes and we create what we call a solid. A solid is like a 3D shape. So I'm looking, for example, this question number one, which is like a prism, a rectangular prism. It says round your answer to the nearest tenth. As a matter of fact, the first four questions are going to be prisms. Now, a prism, but I'm going to explain what a prism is. A figure where the top and the bottom are the same. There's two shapes, and we call them bases. One on top, one at the bottom, and then the sides are all rectangles. Imagine a room. Hope you guys are in the room right now. Look at the top and the bottom. Look at the ceiling. Look at the floor. They look the same. They're the same. Most cases are rectangular prisms, right? That the ceiling and the floor in more cases are rectangles, but it could be a different shape. So you have the bases, top and bottom are the same, and then the rest are rectangles. Interesting part though is the amount of sides the base has. I'm looking at a classroom now that has the bases, the top and the bottom are rectangles, so there's four sides. So the amount of sides the base has is the amount of walls that it has. So, and then the walls, the funny thing is that they're rectangles. So when we're looking for prisms, like I said, we're dealing with prisms at the beginning, I'm going to look for a shape that is not a rectangle. If I look at number two, I can easily see the base, right? I'm looking for a base that is not a rectangle. When the base is a rectangle, like I see in question number one, what I'm going to be looking at is, let me highlight the base. When the base is a rectangle, I'm even going to help you by including the 90 degrees, the four corners of the base. So you guys, let me highlight it. You guys can see that the base is here. It's a rectangle. And then just for highlighting purposes, let me highlight this other one here as well. Because I said there's one on top, there's one at the bottom. Now, areas of rectangles I can do pretty well. So what I'm going to do is I'm going to separate the bases. And I'm just going to draw my two rectangles here. Surface area is basically the area of the outside of the solid. So in this case, the area outside of the figure. So my rectangle, remember I said on rectangles, look for a 90-degree angle and then multiply the two numbers and make that angle. So I'm looking at this corner down here. The two sides are 9 and 11. When I multiply those two sides, 9 times 11 is 99. So I'm going to say each of my bases is 99 square centimeters. Now, I'm not, even though there's measurements here, right, I could write centimeters squared, but in our case, I want to just make sure that you know what you're doing. So I'm not going to ask you for the measurements. I'm just going to ask you for the number. Okay, so I saw the two bases. Good. Now, because the base has four sides, let me add four rectangles in the center, right? Four walls in the center. These are not measured to scale, but now for me to know that the area of each of those rectangles, make sure you know the value of each side on your base. So let me do this in red. One of my sides on my base is 9, the other one is 11, the other one is 9, and the other one is 11. I'm going to multiply each of these numbers times the height of the prism. Now the height is the distance between the bases. So for us to understand it better, for us to see it better, is the number that has nothing to do with your bases, right? The distance between the bases is basically the number has nothing to do with your bases. So in this case, this 6. Okay, so I'm going to multiply it against 6 times each side of the base. So I'm going to go 6 times 9, 6 times 11, 6 times 9, and 6 times 11. So the height of the prisms times each side of the base. That's how I create each of my rectangles. So matter of fact, if you guys call a painter, right, you guys want to paint your house and you call them up and they said, okay, here, look at my wall. How much will you charge me? They're going to charge it based on the area of the wall. They're going to measure the wall as a rectangle, and then they're going to charge you based on that. The walls, you're going to include the ceiling. Well, they're going to include the ceiling. You want to include the floor? They're going to include the floor. Right? I don't know why will you paint the floor, but in case you want to paint it, you can paint it as well. Now, painters are going to overcharge you because the walls, they have they have windows. They're not going to paint the windows, so they're saving some paint there, but they're still going to charge you for that. Okay, so now that I know the area of the bases, I know the area of my walls, I'm just gonna add everything up. So I wanna add my bases first. So 99 plus 99, and let me add the sides. So 54 plus 66 plus 54 plus 66. So I added all six numbers, right? The four walls and the two bases, and in my case happens to be 438. Again, for us to understand, this is for 438 square centimeters, but I'm just going to ask you for the number. It says round it to the nearest tenth if necessary. I don't have decimals, but sometimes I will. Let's take a look at question number 2. My base, remember when I'm looking at these shapes, when I'm looking at solids, I'm looking for a shape that is not a rectangle. When it comes to prism, a shape that is not a rectangle. And in this case, I see a triangle, so that has to be the base. So let me draw two triangles. I'm only going to highlight on my solid one triangle, but you should know there's two. So I'm going to get my two triangles here. And I know I have to still look at the 90-degree angle, which is right here. And it's made by this number, which I know is 3. And it's made by this other side, which I know it's 4. And I know for a triangle, I have to multiply those two numbers. So 3 times 4. Let me write this right here. 3 times 4. But because it's a triangle, I have to divide it by 2. Remember, 3 times 4 gives me a rectangle, but the triangle is half of a rectangle. So 3 times 4 divided by 2 gives me 6. So each of my bases, it's 6. Because the base has 3 sides, I'm going to have 3 walls. Let me get the measurement of each side of my triangles. I know one side is 3, the other side is 4, and the third side is 5. So I get the measurement of each side of my triangle. Then let me get the height of the prism. The number that has nothing to do with my triangles, in this case, is 1. So I'm going to multiply 1 times each side of my triangles. I'm going to go 1 times 3, 1 times 4, and 1 times 5. Now let me add all this. Let me add the walls first. 3 plus 4 plus 5. And then the two triangles, so plus 6 plus 6. And it gives me 24. That's not bad. Let's take a look at question number 3. I'm looking for a shape that is not a rectangle, because that's going to be the base. And I see it down here. I'm going to highlight 1, but you should see 1 at the bottom and 1 on the top. It looks like a hexagon, right? You guys learned the names of these figures in first semester. So a figure with 6 sides. Okay, that's not bad. Let me just go here. Now, a polygon, right? A hexagon's a regular polygon. I can see based on the base on the top that all the sides are equal, and I can tell that all the sides are 7. The measurement of each side is 7, so I'm gonna say this side is 7. Now, the area of a polygon, of a regular polygon, we talked about this last week. Look for a triangle inside. The 90-degree angle, it's made by 7 and 6.1. The measurement 7 and 6.1. So I remember I came and I said look for the area of that triangle. So I'm gonna go 7 times 6.1 divided by 2. That's the area of that triangle. And then for me to know the area of the whole polygon, I'm going to multiply whatever I get for the triangle. I'm going to multiply this by 6 because there are 6 sides. So I'm just going to grab my calculator. I'm going to go 7 times 6.1 divided by 2 and then times 6. So I get 128.1. All right, so 128.1. So each of my bases, there's 2 bases, each of them is 128.1. My base has 6 sides. So let me get 6 rectangles in the center, right? 6 walls. This was a room. This is what we call a wall. Now, interesting is that each side of my base is 7. So the same number. So I'm going to get the same number for each of my walls. And I'm going to multiply each of those 7 times the height of the prism, right? The distance between the bases. In this case, 12. Now, let me emphasize the height is not always up and down. Imagine you as a person, you know your height. Now lay down. Your height is still the same measurement, but it's going sideways. So it's not always up and down. So again, for each of my walls, I'm going to multiply 12 times each of my sides. So I'm going to go 12 times 7. It's going to give me 84. So each of my walls is 84. All right, so I'm going to add them all up. Let me do the walls first. I can go 84 plus 84 plus 84 6 times, but I remember back in elementary school, and I don't know, probably 3rd grade, when 2nd grade, 3rd grade, you guys learned that when you're repeated addition is multiplication. So instead of going 84 plus 84 plus 84 6 times, I'm just gonna go 84 times 6. Okay, so it's easy because they're the same number. So I just went 84 times 6 plus 128.1 plus 128.1. My result gives me 760.2. Okay, so that's not bad. Remember, I encourage you guys to see it as 2 bases in a bunch of walls, right? Some walls at the side, some rectangles. Let's take a look at question number 4. Let me highlight one of the bases. In this case, it's a pentagon. For prisms, again, I'm looking for a shape that is not a rectangle because the prisms have 2 bases, one on top, one at the bottom, and the rest are rectangles. All right, so I already found the base is a pentagon. In this case, it's a regular pentagon, right? All the sides are equal. So I remembered. I remember for regular polygons. Remember, many, gon, sides. So a figure with many sides, in this case with 5 sides. We talked about this last week. I'm going to look for a rectangle. I know each measurement outside is 11. Based on this little slash and 11, I know each measurement outside of my base is 11. So for that triangle, just to get the area of that triangle that I highlighted, is going to be 11 times 7.6 divided by 2. Okay, so that's that triangle. To know the area of the whole polygon, my result, let me multiply this by 5. There are 5 sides of my polygon. So that's why I multiply by 5. So 11 times 7.6 divided by 2 times 5, it gives me 209. Okay, so each of my bases is 209. I highly recommend to see how I'm drawing my shape. I draw the 2 bases and then rectangles in the center. Highly recommend do the same. Okay, my base had 5 sides. So I'm gonna do 5 rectangles in the center. Now, some people might be, well, if I'm drawing this, I'm not doing math. Well, yes, you are. In mathematics, we call this net. When you break down a figure, a solid, a three-dimensional shape, you break it down into two-dimensional shapes. We call that a net. So yes, you're doing mathematics. Okay, so I know each measurement outside of my base is 11, right? I can do this 11, this is 11. And I know the height is 9. The height of the prism is 9. So I'm gonna go 9 times 11 for each of my walls. So that gives me 99 for each of my walls. All right, so let me add everything. I'm gonna add 99 5 times plus 209 plus 209 gives me 913. So that's not bad. Let's continue to question number 5. By the way, today I'm gonna be working up until number 20. So let's take a look at number 5. Okay, a cylinder. Okay, so now my cylinder, I see a shape that is not a rectangle, right? So I'm gonna do my 2 circles here. Now for my cylinder, I need the radius. Be careful what I give you. Sometimes I might give you the information of the radius. Sometimes I might give you the information of the diameter. For us to remember, let me draw 2 circles here. The radius is only half of the circle. The diameter is a segment that crosses the whole circle. So I might give you the radius, I might give you the diameter. You do need the radius, okay? So my radius in this case is 8. You guys see the diameter is 16 kilometers. So the half of 16 is 8. So that's my radius. And I know we talked about last week of areas of circles. I showed you how to do it. Remember, it was a circle, we cut it into pie shapes, or like almost look like triangles, and I put them together. I gave you guys a formula of circles. Yes, I mean last week. So we're looking at the radius is 8, and I remembered the area of a circle was radius squared pi, radius squared times pi. Okay, so I have to go radius times radius. That radius is 8. So I'm gonna say 64 times pi. Let me deal with the symbol pi for right now. I'm gonna have to deal with it later as a decimal. So I'm gonna write it right now as 64 times pi, or 64 pi. Remember the 64 because I went radius times radius, 8 times 8. And obviously the other base is gonna be 64 pi as well. Now, when when we're looking at the center, we're like, center, should that be a rectangle, or what shape should that be? And then in this case, actually, it does happen to be a big rectangle. Imagine a soda can, right? Imagine a soda can. That's that's a cylinder. It almost looks like a cylinder. If you cut the top and cut the bottom and you open the thing up, you cut it up, it opens a big rectangle. Interesting part of this rectangle, the height is the small side in this case is going to be 4. So let me use red, and I'm getting that 4 from the height. Right, the number has nothing to do with my circles. That's going to be this small side of my rectangle. Again, my figure is not measured to scale. Then the long side of the bay of the rectangle, to be honest, it is the distance around the base, which I remember we called it diameter. I mean, circumference. The circumference, right? The distance around the circle, the circumference. I gave you guys 2 formulas. I said you guys could go diameter times pi, or you guys could go 2 times radius times pi. It's the same thing, right? 2 times radius is the same thing as the diameter. I can even use the radius 8 times 2, or I can use the diameter that was given initially. Either way, I'm gonna get that this whole side right here, it is 16 pi. I'm doing in red, it's outside of my rectangle. And then I know one side is 4. The short side of the rectangle is 4. The long side of the rectangle is 16 times pi. Let me multiply my numbers because I know for a rectangle I have to multiply that. 4 times 16 pi. Let me multiply my numbers. 4 times 16. So that gives me 64 pi. Okay. Let me add my two circles plus the rectangle in the center. I'm just looking at the 64s. So 64 plus 64 plus 64. Or some of you might have said 64 times 3. Okay, it gives me my whole area here. It is 192 pi. 192 pi basically means 192 times pi. Okay, so I know I've been told before, use 3.14 for pi. So I'm just going to go 192 times 3.14. According to my calculator, it says 602.88. But my answer says rounded to the nearest tenth. My second decimal number is big enough. So my answer will be 602.9. Okay, now some of you might ask, might wondered, do I have to type in 3.14 for pi, or can I use the key that says pi in my calculator? Now for this homework, I'm gonna let you guys use either one. If you type in 3.14 for pi, you will get 602.9 for your answer. Now, if you type in the key pi, so not 3.14, but pi, so you go 192 times pi, your answer should be 603.2. There's going to be a variance, okay? And I'm going to accept either one. Okay, cool. Now for the spheres, this is pretty cool. You guys can try this at home. You guys grab an orange, grab a grapefruit, grab something that it looks like a sphere. I'm looking at the shape outside. And if you grab a piece of paper, so I'm gonna show you guys, this is something pretty cool. If you grab a piece of paper and then put your orange or your grapefruit or whatever you have, put it on the paper, and with a pencil, draw a circle like around it, as close as you can be. And as a matter of fact, let me draw 6 circles on my paper. Like I said, feel free to try it at home. Now, surface area is basically the area on the outside. In this case, I'm looking at an orange or a grapefruit. I'm looking at the peel, right? I'm gonna peel it off at the outside. If you guys take the peel and you guys take pieces out and you guys start filling the little circles here all the way down, just to see how many circles you complete. Like I said, as try to cover the entire circle. So you might cut a big piece and then some pieces. You end up putting in 4 circles. You end up filling 4 circles. Now, I know the area of a circle is radius squared times pi. That's the area of one circle. Now, 4 circles for the area of a sphere, I'm gonna go 4 times radius squared times pi. Pretty cool. So now this one, my radius is 5, so I'm just going to type into my calculator 4 times 5 times 5 times 3.14. I'm going to use 3.14 for pi. Notice how 5, I did it twice because it was radius squared, so basically the radius twice. So 4 times 5 times 5 times 3.14, and it's going to give me 314. Good. So when it comes to prisms, cylinders, or spheres are not that bad. Just remember, we were looking at 2 bases and then rectangles in the center. When it comes to a cylinder, it's just one rectangle in the center. When it comes to spheres, this is going to be four circles. Now, let me take a look at pyramids. Okay, so I'm looking at my pyramid or cone. Now, here, question number 7, looking at a pyramid. The interesting of pyramid, there's only one base. On one side, there's a base. In this case, my base is a rectangle. Let me highlight it. So we're going to call this rectangular pyramid. The base could be any shape. So there's my base, but each of my corners, I'm going to create a segment that's going to meet on the top. So that's what we do. We create a segment that meets on the top. So there's on the top, it's only supposed to be just one point. Okay, so let me take a look at my rectangle. Let me take a look at my base. It's a 6x3 rectangle. So I'm going to say the area of that rectangle is going to be 18. Now, the interesting part, if I make this flat, remember I talk about nets. You make a solid into 2D, so you make it flat. On each side of the base, you're going to have a triangle. There's going to be a triangle there, triangle here, and a triangle here. Okay. Now, for 2 of my triangles, I'm looking at the triangles on the front. I'm going to multiply 6 times 3.4. So I was looking at the 90-degree angle created here. It was created by 6 and 3.4. So I'm just going to go 6 times 3.4 divided by 2. Remember, for triangles, we do that. So that gives me 10.2. Okay, so 2 of my triangles are 10.2. There's one at the front and one on the back. Now, I see another triangle that is made by the measurements 3 and 4.2. Because I see the 90-degree angles right there. Okay, so for that one, I'm going to have to go 3 times 4.2 divided by 2. Okay, so let me go 3 times 4.2 divided by 2, and it gives me 6.3. Okay, so 2 of my triangles are 6.3. Now, just everything. Add everything. So 6.3 plus 6.3. I'm using a calculator. Plus 10.2 plus 10.2 plus 18. I added all my numbers, and it happens to be 51. Good. Let me highlight my 51. Let's take a look at number 8. Okay, so in this case, for pyramids, I'm really looking for a shape that is not a triangle, because right, the sides are going to be triangles. Now, when the base is also a triangle, I'm going to highlight which triangle is it. That way I'm going to highlight it for you. I'm going to give you the 3 measurements of that triangle. So the base is the one triangle where you know the measurement of each side. So an example, I know this side is 5. Right, there's a 5 that is pointing to that side. I know this other side here it is 5. And then I know this other side here is 5. Okay, so you can see which one is my base. Okay, those 5s were for me to identify which one is the base. Now, I'm gonna get the area of that base, the area of that shape. Now I'm looking for a 90-degree angle. Remember, those 5s, I'm not gonna use all of them. It was just for me to know which one is the base. Now, there is a 90-degree angle made by 5, by this 5, and this 4.3. There's a 90-degree angle there. So I know for the base, I have to go 5 times 4.3 divided by 2. So 5 times 4.3 divided by 2 happens to be 10.75. I know my instruction said round your answer to the nearest tenth if necessary. This is not my answer. This is my work, so I'm not rounding just yet. Okay, so 10.75 for the base. And then I know each base is going to have a triangle. Each side of my base is going to have a triangle. So there's going to be, in this case, 3 triangles. And the funny thing is that they're all the measurement. The base is 5 on each side. So each of my triangles is going to have the same measurement. All right, so let me just solve for one. And all 3 are going to be the same. Now for this triangle at the side, I'm going to use this 5. I'm going to highlight it in green with 6.2. And I know for that one, I have to go 5 times 6.2 divided by 2. And that happens to be 15.5. So each of my triangles here, it is 15.5. So now that I have everything that I need, let me add my 3 triangles. So 15.5 3 times plus 10.75. According to my calculator, I get 57.25. But I know I have to round it to the nearest tenth, so 1 decimal place. My second decimal place is big enough, so that 5 is going to push the 2 over. So my answer should be 57.3. Nice. Now let me flip the page. Let me take a look at question number 9. Still a pyramid. Still a pyramid, so let me identify the base first. So in blue, in this case, let me use blue. I see a shape that is not a triangle, so that's definitely the base. In this case, it has 6 sides, so it's a hexagon. So let me draw my hexagon here. Now remember, for regular polygons, I'm gonna just get a triangle. So I'm looking at this triangle in here. I know each measurement outside is 7. I'm gonna use the 7 times 6.1 divided by 2. That gives me that triangle. And whatever I get in this case, I'm gonna multiply by 6. And then I multiply by 6 because there are 6 sides, so there's 6 triangles in there. So let me go 7 times 6.1 divided by 2 times 6. So I get 128.1. Then on each side, there's a triangle. So in this case, there's 6 triangles. Then for my triangle, I'm going to use 7 times 12.6. So for that one, I'm going to go 7 times 12.6 divided by 2. And I get 44.1. So each of my triangles is 44.1. Okay. Now add everything. We're going to add 44.1 6 times plus 128.1. And I get 392.7. Now, for question number 10, if I make this flat, when I look at a cone, if I make this flat, I can see there's going to be a circle. So I'm just going to say there's a circle. Now the top, if you guys ever try it, you guys come over and grab a cone, hold it in a piece of paper, you guys cut it out, and you guys expand it. It's going to expand to some shape that looks like almost like half of a circle, almost. Okay. Now I know the radius is 3, so my circle's not that bad. Radius squared times pi, right? Radius times pi. For right now, let me just call this 9 pi. My circle's easy. Let me just call it 9 pi. Now my other shape, this other shape, I'm gonna have to multiply my radius. I know my radius is 3, so my radius times my lateral height. Lateral height is this measurement at the side. We call the lateral height because it's the height of the side, of the distance of the side. It is not quite the height of the cone. Let me emphasize that. The height of the cone will be right here in the center. Let me highlight this as h, the height. So it is not quite the height of the cone, is what we call the lateral height, which in this case is 11.4. So radius times lateral height times pi. I'm going to use that. So I'm just going to go, for right now, let me just go 3 times 11.4. So I'm just going to call this 34.2 times pi. I don't want to deal with so many big decimals, right? Pi is a big, big decimal. I don't want to deal with it just yet. Okay, so now let me add these two measurements, 34.2 pi plus 9 pi. That gives me 43.2 pi. Okay, now let me do get the decimal. Let me go 43.2 times 3.14. According to my calculator, I get 135.64. Okay, this second decimal number is too small, so I ignore it. So my answer will be 135.6. If instead of using 3.14 for pi, you literally go 43.2 times pi, now that should give you 135.7. Okay, that's not bad. Now, let me talk about volume, right? That was surface area, but here you could are also going to deal with volume. Now, volume, let me explain it in this shape right here. Now, volume is, I have a solid, in this case, a rectangular prism. You guys see the top and the bottom are rectangles, so that's why I call it rectangular. And the walls at the side are rectangles as well. Okay. Now, here, volume means how many cubes can I put in it? How many cubes are in there? And we could count them all. I could count them all. I know I don't see them all because there's some of them hiding right there underneath other cubes. But if I was to look at notice how I colored the shape at the bottom. 5 blocks on the front and 4 blocks on the side. I'm looking at this shape right here. I'm just imagining that base. Right, there must be 20 cubes there. I'm just looking at this base and this is 20 cubes. Then I'm gonna say there's also 20 cubes here and 20 cubes here, right? 3 times because the height is 3, so it makes sense there's 3 of them. If I add them all, right, there's 3 layers of 20. I could add them all. We can say it's 60. Now, I'm gonna show you guys something really cool. For volume, the volume of prism, so it's a rectangular prism, triangular prism, any type of prism, it's gonna be the area of the base. You guys notice how we got the 20 from the area of the base. So the area of the base times the height. Right? The base was a 5 by 4, so 20. The height was 3, so 20 times 3. So volume is going to be, remember, volume of a prism. Okay, remember prism is top and bottom of the same base, and then the rest are rectangles. So the volume of a prism is going to be the area of the base times the height. Okay, let's play a little. Let's take a look at question number 11. Find the volume of each figure, round your answer to the nearest tenth if necessary. Okay, so I'm looking for a shape that is not a rectangle. When I'm dealing with prisms, I'm looking for a shape that is not a rectangle. If it is, the base is highlighted with the four corners of 90. Now remember, volume is going to be the area of the base times the height. Now my base, I can see is a 10 by 7 rectangle. So I'm just going to say 70, right? Because 10 times 7. And then the height, the number that has nothing to do with your bases, it's 11. I remembered. I remember I said the base is not always up and down, right? Your height is not always up and down. If you're laying down, it's not up and down. So don't think the height is always up and down. Okay, so the base is 70, the height is 11. 70 times 11 is equal to 770. Now, one thing for measurements. For my answer, I'm just going to expect the number, so 770, we're good. One thing for measurements. The area was 70 miles square. Miles square because I went miles times miles, so miles square. The height was 11 miles, except for measurements. The number was 770, so that was good. But here, I'm going to have to do miles to the third power, because miles squared times miles, I multiplied miles 3 times. So miles to the third. So we're going to call cube miles. That's why in volume, the measurement is going to be cube to the third. And it makes sense because I'm asking how many cubes are in there. Okay, again, I'm just going to get the number. You don't have to get the measurement, but measurement is important, like in physics and other classes. Okay, so question number 12. The area of the base times the height. That's the volume. So I got to figure what's the base, what's the area of the base. And I see a triangle here at the bottom. And I see my 90-degree angle is made by these two sides. I'm going to say one side is 3 because it's the same as this side. And the other side is 4 because it's the same as this side. I don't have to use all my measurements, okay? So for my triangle, I know I have to go 3 times 4 divided by 2. That's going to give me my base. Now, the height is a number that has nothing to do with my triangles. My question is it the 5 or the 10? There's two numbers I haven't used. I know the 5 is the measurement of one side of my triangle. So this case is going to be 10 because I said before, the height is a number that has nothing to do with the base. That 5, to be honest, I'm not going to use it at all. Okay, so I'm just going to go 3 times 4 divided by 2 for the base. That's 6 times 10. My answer will be 60. Cool, that's not bad. Let's take a look at number 13. The base is a polygon. Remember, volume is the area of the base times the height. So I'm looking at this 5-sided figure. But in there, I just want to look at a small triangle. And I know each measurement outside is 10. So for that triangle, I'm going to go 10 times 6.9 divided by 2. That's just that triangle. Now for the whole base, it's going to be times 5. So that gives me, let's see, 10 times 6.9 divided by 2 times 5. It gives me 172.5. That's the area of the base. Now the height is this 10. 172.5 times 10 is 1,725. Okay, let me talk about the thousands here. I know before we were told add a little comma in between the 1 and the 7 to separate the thousands from the hundred. So 1,725. If you add the comma all together, right? There's no spaces. If you add the comma, awesome, good for you. If you don't add the comma, you just add the digit, you just type in the digits 1725. Awesome, good for you. Now, what I'm trying to say here is the comma. I'm not gonna mark you absent for something so simple. I'm not gonna mark you wrong for something so simple. If you type in the comma or not, it's up to you. Either correct will be either answer is gonna be correct. Okay. So type the comma 1,000, comma 725, or don't. Up to you. Either answer is correct. Let's take a look at number 14. The base, it's a hexagon. And I know volume is the area of the base times the height. And I'm looking in here at a one little triangle. I know each measurement outside is 8 of my base. And again, I get that from this last 8. Okay, so for that triangle, just that triangle alone, I have to go 8 times 6.9 divided by 2. Whatever I get, I'm going to multiply this by 6. There's 6 sides of my base. So multiply by 6. So 8 times 6.9 divided by 2 times 6, it gives me 165.6. So the area of the base is 165.6. The height in this case is 10. Let me multiply those two measurements. So 165.6 times 10 is going to give me 1,656. Let's take a look at number 15. The area of the base times the height. Okay, the base is a circle. Because I'm looking at sideways from not from the side, but my perspective, it looks like an oval, but it really is a circle. My diameter is 12, so I'm gonna say the radius is 6. So the area of my circle is gonna be 36 pi. Remember, I have to go radius times radius. So 36 times pi. The height in this case is 8. All right, so let me go 36 times 3.14 times 8. According to my calculator, I get 904.32. My second decimal number is too small, so I'm just going to ignore this. So my answer is 904.3. Now for the sphere, let me just give you guys the formula for now. I'll explain later in a minute how the formula got derived. Okay, so for now, let me just give you the formula. The formula for the volume of a sphere is going to be 4 times radius times radius times radius. So radius cubed times pi. And whatever I get, I'm going to divide this by 3. So again, for right now, let me just give you the formula. In a minute, I'm going to explain, well, more than a minute. In a little, I'm going to explain how this formula gets derived. So in this case, let me go 4 times 0.5 times 0.5 times 0.5 times 3.14, all of this divided by 3. Okay. So 4 times 0.5. I'm using my calculator. According to my calculator, I get 0.52. Okay, my second decimal place is too small, so my answer will be 0.5. Okay. Now, let me take a look at question number 17. Area of a pyramid or a cone. We're going to start with a pyramid. One cool thing about pyramids, we know that a prism, we know a prism already is base times height. So here in the left, you guys see I have a prism, it's base times height. If I had a pyramid with the same base and the same height, and I fill this with water to see how many pyramids I can fit in one prism, it would take me 3 pyramids to do it. If you guys want to, you can come to our offices and I'll show you. It's pretty cool. There's 3 pyramids in one prism. So again, I know prism is base times height. So for me to get that volume of one pyramid, I'm gonna go base times height divided by 3. Pretty cool. So now let me come back to question number 17. Let me remember the area of the prism is base times height. So pyramid is going to be base times height divided by 3. And the reason, like I said, it takes 3 pyramids to do one prism. So now again, let's go back to number 17. I just learned the pyramids and cones is going to be, the volume is going to be base times height divided by 3. So the base in this case is a rectangle. So I'm just going to call this 48, all right, because 8 times 6. The area of a rectangle, the base is a rectangle. The height of this pyramid is 5. I can see it, it's 5. It's right here. And whatever I get, I'm going to divide this by 3. So I'm going to grab my calculator. I'm going to go 48 times 5 divided by 3. And it's going to give me 80. Let's take a look at number 18. The volume of a pyramid or cone is going to be base times height divided by 3. The base is this triangle here at the bottom. I know I have to look at the 90-degree angle. I have to go 8 times 6 divided by 2. So my triangle is 8 times 6 divided by 2. That just the base, right? So 8 times 6 is 48. 48 divided by 2 is 24. So the area of the base is 24. The height in this case is 10. You can see it up here. The height of the pyramid is 10. And whatever I get, I'm going to divide this by 3. So 24 times 10 divided by 3, I get 80. Lastly, let's take a look at number 19. Well, not lastly, number 19. We're almost there. Area of a pyramid or cone is base times height divided by 3. The base is this hexagon. And I know for regular polygons, I have to get this triangle here. I know each measurement outside is 7. So if I'm just looking at that triangle, I'm going to go 7 times 6.1 divided by 2 for the just one triangle. For the whole base, I'm going to multiply this by 6 because there are 6 sides. So let me go 7 times 6.1 divided by 2 times 6. So I'm gonna get the area of the base is 128.1. The height is 11. The height of the pyramid is 11. And let me divide this by 3. So 128.1 times 11 divided by 3. It happens to be 469.7. And lastly, let's take a look at number 20, my cone. My volume is going to be the area of the base times height divided by 3. The base is a circle, the radius is 10. So let me just call this 100 times pi, right? Radius square pi, that's the area of the circle. That's the base. The height of this cone happens to be 20. And whatever I get, let me divide this by 3. So let me go 100 times 3.14 times 20 divided by 3. According to my calculator, I get 2093.33. Second decimal number is too small, so my answer is going to be 2093.3. Okay, I mentioned I was gonna tell you guys how the formula for a sphere comes up. So I'm gonna explain that right now. Okay, formula for a sphere. I mentioned earlier that I just gave you guys the formula for the sphere, right? I said 4 times radius cubed times pi over 3. Now the interesting part is that now we know the volume of a cone. We know a cone, the volume is the area of the base times the height divided by 3. Then let's say I had a sphere that has the same height. Let's say that's a sphere that's the same height. If I was to fill up my cone, it takes me 2 cones. If I fill it with water, it takes me 2 cones to fill up a sphere. So I'm going to say 1 sphere is equal to 2 cones. Okay? So again, 1 sphere, let me explain that here. 1 sphere is equal to 2 cones. Now I know 1 cone is base times height divided by 3. So 1 sphere is going to be 2 times base times height divided by 3, because I have 2 cones. Now the base is a circle. So when I'm looking at the base, it's going to be radius times pi. Now the interesting part is that the height, because 1 cone has the same height of the sphere, when I'm comparing this, I'm going to say the height is going to be 2 times the radius, because the whole height of my cone will be my whole diameter. So now I have 2 times radius times pi times 2r over 3. When I simplify this out, when I multiply my numbers on the top, 2 times 2 is 4. When I look at my radius, I have radius 3 times, then there's a pi over 3. So I said I was going to come back, and I was going to show you guys how the formula got derived. If you guys are interested, that's how we do it.